Hello, chemistry students. We are going to start looking this week at reviewing the kinds of questions that we have been doing since we started online work. So we are going to review in today's set of questions. We're going to review how we use a balanced equation, what that reveals to us. We are going to review writing mole ratios. We are going to review basic stoichiometry, and we're going to review limiting reactant, and then I'm going to peek at talking about what theoretical yield and percent yield means. But really, this is the end of this chapter's discussion on using information. So we'll be reviewing and then hopefully preparing ourselves for an assessment the following week after Easter. Okay, so we'll spend review time this week. So the first question that I would like to do for you in preparing for this review is number 47 on page 392. So if you would please turn there so that you can read along with me and work along with me, and we will move through this. If this gets long, this will be 2 videos. Hopefully I can get this done in one. So this says when hydrochloric acid solution reacts with lead to nitrate solution, lead to chloride precipitates, and a solution of nitric acid is produced. So here's one thing I would encourage you to do. Why don't you stop? If you can stop the video, you can see if you can write this balanced equation, all right? And then you could check yourself, sorry. So this says hydrochloric acid is reacting with lead to nitrate, and I know that nitrate, you might have to look that up, but nitrate is NO3, and since it's lead 2, that means there has to be 2 of them. If you remember from your list, nitrate is a -1 ion, and then this is going to make PbCl2, lead chloride. Again, the lead here has to be a 2 plus lead, because it would not change its identity, what it was doing here. And then nitric acid, and so acids have hydrogen in the front, so that's HNO3, all right, and then we need to balance this. So let's look, we need 2. We have 2 nitrates here, so we're going to need 2 nitrates here. So I'm going to put a 2 here. And then I have 2 chlorines here, and this has changed this to 2 hydrogens. So to balance that, I will need this to say 2 hydrochloric acid plus 1, 1, and 2. So that is the way that I would balance that equation. Now, this question is going back to the very beginning of our work together, where it's asking us to evaluate this balanced equation. So we know that we can interpret a balanced equation in terms of particles, and that would be atoms, moles, formula units, and ions. We can interpret in moles of all of these things. And then the last one is indirectly, we can interpret according to mass. So let's get that done. So this means that we have 2 molecules of HCl. I am going to run out of room. We have 2 I'm going to write them in a list like this, okay? 2 molecules of HCl, 1 formula unit of PbNO3, 2. This is a formula unit because these are ions. 1 formula unit of PbCl2, because this is an ionic compound, a metal and a nonmetal. And then 1 molecule of nitric acid. I'm sorry, I made an error. That would be 2 molecules, because of my coefficient there, 2 molecules of HNO3. Now the next thing we're going to do, so that's our particle. So the next thing we would do is moles of these. So I'm going to do my mole column over here just to save us a little bit of room. So this would be 2 moles of hydrochloric acid, 1 mole of this, 1 mole of PbCl2, and I did it again, and 2 moles of nitric acid. So 2 molecules, 2 moles, 1 formula unit, 1 mole, 1 formula unit, 1 mole, 2 molecules, 2 moles. That makes pretty good sense to us. Now we get to interpret this according to mass. And I actually am going to write dark, but I'm going to use a smaller pen so that I can possibly get all of this on this one page for us. So when it comes to mass, so then we're going to take the mass of the molecule and then multiply it by 2. This is because we're trying to show that this reaction honors the law of conservation of mass, so we don't lose anything. So here we would have 2 times 1.01 for the hydrogen plus 35.453 for the chlorine. So that would be a total mass of 72.908 grams represented by the hydrochloric acid. Then we're going to add that to the mass of this. So this is 1 lead, so lead is 207.2. And then we have to add in this polyatomic ion times 2. Well, this is 14 plus 16 times 3, because there are 3 oxygens, and then that whole thing has to get multiplied by 2. So here, this then is, so 16 times 3 plus 14 times 2 plus 207.2. Let me do that again. 16 times 3 plus 14. Then we're going to multiply that whole thing by 2 because that's the mass of this, plus 207.2. So that's going to give us 331.214 grams is represented here. All right, now let's move to our, now let's just add this up. So in our reactants, we have 404.122 grams of reactants. Now let's see what we have in our product side. Our product side, we're going to have, so we've got 207 for the lead, 207.2, plus 2 times 35.453. So 2 times this plus this, that gives us a mass of 278.106 grams. And then let's do the nitric acid. And the nitric acid here is, I know I'm writing small, I apologize. Hopefully you can see these numbers. I'm just walking you through the process. So this, I'm going to drop down here. So this will be 2 times, and it has to be doubled because there are 2 moles of this. So 101 for the hydrogen plus 14 plus 16 times 3. Okay, so we're going to multiply that out. So 16 times 3 plus 14 plus 101, then multiply that entire molecule by 2 to get us a mass of 126.016. And now we add those 2 up, and we see that. Now here we can write equals because this mass equals 404.122 grams. So we have interpreted this balanced equation in terms of particles, in terms of moles, and then in terms of mass. When you're asked to do this in an evaluation, you would need to put your supporting work. How did you come up with this? So in a sidebar, or come up with your molar masses of these so that it shows. You cannot just show me this number equals this number. You have to be able to show your work. Okay? Now let's look at question number 48. And I do think I'm going to divide this review section up so that you so that these won't be too big or too long. All right, so let's look at question number 48. This one is shorter. So if we're looking here at question number 48, this says, when aluminum is mixed with iron 3 oxide, iron metal and aluminum oxide are produced along with a large quantity of heat. What mole ratio would you use to determine this? So they give us a balanced equation here. So we just need to pop that in. Remember, your balanced equation has to be on every stoichiometry problem that you submit for me so that I can see what you're referencing and you can reference it if you need to. And that just gives us something, sorry, that should be an oxygen 3 plus a bunch of heat. All right, so this just means this reaction is exothermic. So iron oxide is reacting with aluminum to produce aluminum oxide, that's Al2O3, and then a whole bunch of heat is given off. So this is an exothermic reaction. So that heat is being given off to the atmosphere. So the question here then is, it's not asking us for a specific number. It asks us if we know this, if we know something about iron 3 oxide. If we know something about iron 3 oxide, what mole ratio would we write to find out how many moles of iron? So this is really just asking us for the mole ratio that would solve this problem. Well, mole ratios, remember, we could write a mole ratio. We could write every mole ratio, and there would be 12 of them. 1 mole to 2 moles, 1 mole to 2 moles, 1 mole to 1 mole, 2 moles to 1 mole, 2 moles to 2 moles, 2 moles to 1 mole, 2 moles to 1 mole, 2 to 2, 2 to 1, 1 to 1, 1 to 2, 1 to 2. We could write them all and then identify the one, or we can just look at this and go, if I'm going to solve this question, what is the mole ratio? And the mole ratio would be what I want to find out has to be on top. So 2 moles of Fe over 1 mole of Fe2O3. All right? So that is that is the answer to this question. What mole ratio? The question was, what mole ratio is required to solve this problem? Now, we don't know the number of moles here, so we can't actually solve anything, but this is the mole ratio that would solve the problem. All right, now from this question, from this review, your task then is to find answers to number 50 and number 53 on this very same page, page 392. So that's a review question from the very first section.